Welcome to episode 3. Today we will be looking at measuring light and dark in a meaningful way for photographers. We will be looking at the units we use and some of the ways that they can be useful. So, when we are talking about how much light to let into the camera or how sensitive the sensor is going to be, we need some measure to quantify it. In photography, that unit is the stop. Stops are not an absolute measurement value. Instead, they represent a doubling or halving of the amount of light or the sensitivity. In the early days of photography, the amount of light that could be coming through the lens in an amount of time was controlled by placing metal discs with different sized holes in them in the lens. These discs are still used in many optical labs and are called stops. This is a sequence of patches progressively getting one stop brighter over the full range that one of my cameras can record. The changes at the two ends can be quite hard to see. Most monitors can only really show between 6 and 8 stops of brightness when correctly set up. Unfortunately, most monitors are not correctly set up. Also, there is not a full stop of difference in brightness between the first and second patch or the last two patches. In the darker patches, the image cannot get any darker once it has reached this point thanks to electronic noise generated by the sensor itself. In the brightest image, it is fully overexposed. In the parlance of my last video, the buckets all overflowed. In either case, that situation probably won't occur at a stop boundary. So here we have 10 patches representing between 8 and 10 stops of light. The controls on vintage, mechanical, manually operated film cameras generally only allow you to adjust the exposure in full stop increments for both the aperture and shutter speed. Given the nature of films in use at the time, this level of adjustment was perfectly adequate. Some of the later film SLRs, as well as digital cameras with manual controls, will generally offer you a choice between adjusting in 1/2 or 1/3 stop increments. 1/3 stop increments is a good choice as it represents a point close to which it is no longer possible to discern the brightness change in the final image. So now we have stops out of the way, this is probably a good time to talk about another important concept that is related and necessary to comprehend. That is the term middle grey. Middle grey is a tone that is perceptibly seen as halfway between black and white in a lightness scale. The perceptual bit is important as our eyes do not see light in a linear way, but logarithmically. There are several different ways that middle grey has been defined over the years, as well as scales over which it has been measured. The International Commission on Illumination, more commonly known as the CIE, has been the international standards body for light, illumination, colour and colour spaces since 1913. One of the oldest standards, predating the CIE even, is the geometric mean intensity of a 60:1 ratio between black and white. This has a CIE XYZ illuminance of 12.91%. The traditional value used in photography and printing is 18% grey with a CIE illuminance of 20%. Then we move to digital and have the sRGB IEC 61966-2.1 standard that is widely used for digital output devices such as monitors, as well as for image files themselves. sRGB has an illuminance of 21.4%. As you have been able to see, the differences in brightness of these different standards of middle grey are not big. So now we have a definition of middle grey that we work with photographically, 18%. It now also turns out that an average scene reflects between 12 and 13% of the light falling upon it. Light meters for cameras are calibrated to the 18% grey figure. What this means is that if you have a solid bright white subject that fills the camera's full metering area, it will be recorded as middle grey. It was this method that I used to generate the mid-tone level output from the camera used for this example. So with the scene reflecting 12.5% and the meter calibrated to 18%, the image will be recorded about 1/3 of a stop too bright. The other significant thing this leads to is that if we double 12.5% 3 times, we end up at 100% brightness. So we will always have 3 stops of difference between the brightest white possible and the middle grey of our images. If we have a meter that can measure a small part of the image, it is possible to choose what brightness level within the scene is recorded as white. Simply take the meter reading and then add the 3 stops of difference between mid-grey and bright white. We often refer to the mid-grey tone as being 0 EV, where EV stands for exposure value, with bright white being +3 EV. Brightness levels below the mid-tone get negative values. There is another exposure system that also uses the EV scale to match camera settings to illumination levels. In this case, the complete set of aperture size and shutter speed that will give the same quantity of light to the image plane have the same EV numbers. In this case, the combination that has a shutter speed of 1 second and an f number of 1 is EV0. So 1 second at f1, 2 seconds at f1.4 and 30 seconds at f5.6 are all EV0. At the same time, exposures of 1/250th of a second at f2.8, a 60th at f5.6 and an 1/8 of a second at f16 are all EV11. Remember that with apertures, the larger the diameter of the hole, the smaller the f number. Sometimes you will find this same EV system used for things like the minimum and maximum illumination levels that various camera systems will operate between. Examples here include the camera's auto exposure and autofocus systems. In these cases, the camera settings are accompanied by an appropriate ISO setting. If you do not see an ISO mentioned, then it will be ISO 100. You will also see the ISO value subscripted to the EV itself in the text on occasion. So, in conclusion, call it what you will, a stop, exposure value or EV, it represents a change that is a doubling or halving of the exposure, illumination or brightness. This is the most important thing to take away from this presentation. Oh, and look on the bright side. I didn't go into any of the mathematical derivations of this stuff. So, I hope you enjoyed today. If you did, give it a like. If you didn't, a thumbs down is fine. Also, if you haven't subscribed, please do. It all helps the channel grow. If you have any questions, please ask them in the comments. I'll try to answer them there, or at least let you know that it will be coming up in a video soon. Thanks for watching.